Our next question is, a binary operation stays on a set of rational numbers is defined by x operation y equals to x squared minus y squared over 2x y. Find the value of it. So we get started. That is our next question. So we have x operation y equals x squared minus y squared over 2xy. And if you look at the question, it's defined on rational numbers. All right. So if I must add it to more things, for all, remember we use this for all x and y which came from set of rational number, simply means that x and y are rational numbers. All right. So with this formula, we are asked to evaluate -5 operation 3. All right. From the formula, whenever two elements combine to be the first square minus the second square, then divided by 2x, then 2 times the first, then times the second from the formula. All right, so here our x is -5 and our y is 3. So here we have the first element squared, which is -5 all squared, then minus the second element, which is square again. So I have 3 squared, then divided by 2 times the first element, and the first element is -5, then times the second element, which is 3. So in the end, we are left with -5 all square. So -5 all square is -5 times -5. Negative times negative, positive. 5 times 5, 25. So it's going to be positive 25, which can be written as 25. Now, some people make this mistake. Please bear it in mind that -5 square is not the same thing as -5 all square. They are two different things, okay? So -5 square means that the square only belongs to 5. And negative is separate, but -5 in bracket all square means both the negative and the 5, all of them are squared. So all of them are multiplying themselves twice. So this is -5 squared is what? 25. This is -25, but this is what? 25. All right? So be conscious of that. Then -3 times 3. 3 squared is 3 times 3, which is what? 9. All over. This is positive. Positive times negative, negative. Times another positive. So positive times negative, negative. Negative times positive, another negative. 2 times 5 is 10. 10 times 3 is 30. So in the end, this will be equals to 25 minus 9 should be 16. Then divided by -30. 2 here, 2 is common in between 16 and 30. So 2 here is 8, and 2 here is 15, which is, remember that even the negative is at the bottom or at the top. That is, whether the negative sign is at the denominator or numerator, you can still bring it to their left side, all right, or to their right side, like this, to their right side. Okay, so we have this is -8 over 15. So there's nothing common that could cancel. So this is the lowest term. It's a proper fraction. -8 over 15, which is C. Then we have the next one. Let's solve this number 4. I'm still coming back to this. This is identity element. We'll still come back to that. A binary operation asterisk is defined by x operation y. So here we have x operation y, that is the definition, equals to x raised to power y. Then I'll give you a conditional statement that if x operation 2 is equals to 2 minus x, you should find the values of x. Meaning, for we to have values, that is a plural form, that x will contain more than one value. All right. So if that is a conditional statement, if is a conditional statement. So if x operation 2 is equals to 2 minus x, find what? Values of x. All right. Now this is the general formula. This is general formula. Okay. So with this general formula, they have already given us that x combined with 2 is 2 minus x. From this general formula, we can actually find this value. All right. So we are going to begin. So let's start it. So this will be our first equation. All right. So we'll form two equations in this case. That x operation 2 equals to 2 minus x. That is the conditional statement they gave us. Then this can also be replicated from the general equation. The general equation says whenever two elements combine, is going to be the first raised to power the second. So if we replicate this, if we now redefine this with the general definition, so we now have that x operation 2 will be equal to, so in this case, x remains x, all right? And y, okay, x remains x and y remains 2. So it's going to be x from the general definition. So the first element raised to power to the second element. So our second element is 2, so it's going to be x squared, right? So this will be our equation 2. Now remember that this was the conditional statement given to us from the question. Then this is redefining this with the general equation, all right, or with the general relationship. All right, so that is how the second equation was formulated. Now I have to make them look alike so that I can compare. All right, I can compare. So comparing equation 1 and 2, comparing equation 1 and 2. So if we compare, if the same thing is equal to this and the same thing is equal to that, then the two of them are equal. All right. So in the logic, in the case of logic, if A is equal to B and the same A is equal to C, then it is of view that B is equal to C. So if the same value is equal to different value, then those different values are equal. All right. If the same value is equal to different values, then those different values are what? Equal. So from here we have that therefore x squared is equal to 2 minus x. So this is equal to this, since this is equal to this. Okay. All right. So in the end, we solve this quadratically because obviously it's a quadratic equation. So we have that x squared, this 2 is positive, crosses over here, we have negative. Then, okay, let's write it orderly. X is negative here, crosses over becomes positive, and 2 is positive, crosses over becomes negative. So nothing is left here. So here is 0. All right. So of course, we use a quadratic. We can solve this quadratic equation with factorization method. All right, in factorization method, we take the product of the roots. The product of the root is this. So our p, which is the product of the root, is s squared times 2, which is negative 2s squared. Now, if you don't understand this very well, if you don't understand this well or enough, you can watch my videos on quadratic equation. Then this is our sum of the root p, which is positive 1x. So two numbers, if we multiply them, it gives us negative 2. If we add them, it gives us positive 1. And those numbers are from factors of negative 2. So we can have 1 and 2. Of course, 1 times 2 is 2. Then 1 plus 2 is 3. So we can give one of them negative. All right. Let's give, since the sum is positive, so we give the larger number negative, the smaller number negative. Minus 1 times 2 is minus 2. But minus 1 plus 2 is plus 1. So two numbers, when you sum them, they give you the sum of the root, and you multiply them, and give you the product of the root. And that number is negative 1 and 2. Now, for more clarification, watch my videos on quadratic equation. All right, so we now attach those number x. So minus 1x is minus x, and 2x is plus 2x. So we replace the sum of the root with those two values. All right, so let's come over here. So we are left with x squared. So this plus x is replaced with plus 2x, then minus x, then plus 2x minus x, then remaining minus 2 equals to 0. All right, so we group them 2 by 2. So if we group them 2 by 2, it's going to be x squared plus 2x. Then we are left with negative. We factorize negative sign. So this is negative 1. Negative by negative is positive. So we have x. Negative by negative is another positive, which is plus 2 equals to 0. Of course, we factorize completely. We factorize until there is nothing to factorize. What is common here? X. So bring s outside. X divide s squared. Remember, s squared over x. S squared is x times x. Then divided by x. S cancel x. We are left with x. Then plus s divide 2x. This is 2x divided by x. S cancel x, remaining 2. So this is negative 1 into x plus 2 equals to 0. Alright? So in the end, remember we are factorizing completely. So we factorize until there's nothing to factorize. So what is common here? X plus 2 is common. With here, x plus 2 is common. Alright, so we bring down the x plus 2 outside. Then we open another bracket. X plus 2 divide this. So we have x into x plus 2 divided by x plus 2. X plus 2 cancel x plus 2. We are left with x. What is here? Negative. Alright, so x plus 2 divide this. X plus 2 cancel itself, remaining what? 1. So this is equals to 0. Of course, in mathematics, this is product of two numbers to be 0. The only way a number times another number can be 0 is if one of them is 0 or both of them is 0. So if I say a times b equals to 0, the only way it can work out is that if a is 0, so if I say 0 times b to give me 0, or b is 0, so if I can say a times 0 to give me 0. So the only way that two terms multiplying themselves or two real numbers multiplying themselves could be 0 if at least one of them is 0. So we assume in any of the case, so either x plus 2 equals to 0. So in that case, we have that if you make x the subject of the formula, plus 2 plus 0 become minus 2. So we have x is minus 2, or x minus 1 equals to 0. So if we make x the subject of the formula, minus 1 we cross over, or we add 1 to both sides, then we have x to be what? Positive 1. So for more clarification on how to solve quadratic equation, watch my videos on quadratic equation. So hence, x equals negative 2 or positive 1.